Hello, and welcome to my game development coursework video demo. This project is named Project PSE. In the game's setting, the player takes on the role of a job applicant for the Interstellar Corporation, Obsidian Inc., participating in the induction assessment for the role of Energy and Power Grid Systems Engineer. The core gameplay unfolds in a grid-based sandbox environment. Unlike traditional single-resource management games, this project introduces a micro-level dual-dimensional resource system. Players must simultaneously balance power and stability. Different precision devices have strictly different requirements for these two metrics, which forms the core strategic challenge of the game. Next, I will demonstrate the overall UI flow, transitioning from the main menu directly into the level. To match the immersive feel of enterprise software, the UI was built using UGUI with a minimalist, hard-edged industrial style, simulating a real operating system interface. My UI manager actively handles underlying statistics, including real-time FPS calculation, tracking power flow status, and triggering warning logic during grid overloads. Regarding screen adaptation, although the game targets PC platforms, I utilized Unity 6's anchor system for deep responsive design. As shown on screen, even on a 21:9 ultra-wide monitor, the UI intelligently aligns without any layout breakage. Additionally, the dynamic floating UI for individual buildings uses a distance-based dynamic font scaling algorithm, ensuring data remains perfectly legible at any zoom level. Finally, the pre-rendered video contents are prepared in three aspect ratios: 16:9, 16:10, and 21:9. The system calculates the closest ratio to the current screen at runtime and performs smart cropping or filling. In this game, the core gameplay revolves around building a power network on a grid. Players need to strategically place buildings like generators and batteries and connect them with cables to power the target buildings. For the grid and building system, I completely discarded physical colliders and used pure mathematical raycasting against a plane. This achieves lightning-fast grid snapping and dynamic cable drawing. The main technical challenge of this project lies in the power simulation system. I abstracted the power grid into a mathematical graph structure. First, I use breadth-first search to divide physical continents. Then, depth-first search is applied for grid compliance and closed-loop detection to prevent logic deadlocks. Finally, I utilize a distributed energy storage pooling algorithm and topological broadcasting to achieve dynamic load balancing. This power simulation system needs to handle complex and ever-changing power topology layouts, including various extreme edge cases. Because the underlying logic is quite complex, I dedicated a lot of effort to optimizing it to ensure it runs stably and with high performance. The primary level objective in the game is that players must build a logical topological structure to make the target terminal's power and stability meet the requirements. Once the system verifies this, the level is cleared. It's worth mentioning that the game does not restrict the order in which players tackle the levels. It's just like a real exam. Players are free to choose whether to conquer the difficult challenges first or start with the easier ones. Regarding the input system, the game natively supports multimodal input for both keyboard and mouse, as well as gamepads. I also developed a low-level virtual cursor for gamepad players and non-mouse devices like handheld consoles. However, I currently still highly recommend playing this game with a Steam controller. Throughout the game, the company's main AI, Onyx, is constantly present. It's not just a lifeless NPC, but rather a character that intelligently interacts based on player behavior. For its technical implementation, instead of relying on Unity's visual event diagram, I coded a pure C-sharp finite state machine to drive its autonomous logic. In terms of AI behavior, I integrated an AFK timer. When the player stops interacting, the AI autonomously switches between states like idle, watching, and confused. It might curiously observe the player, tilt its head slightly, or even show a confused, "Why aren't you moving?" expression, which significantly boosts the game's immersion. On the animation side, Onyx's visual expression entirely bypasses traditional keyframe animation. Instead, I used Perlin noise to generate smooth, organic wobbles mathematically. By combining coroutines with a custom easing function, I achieved seamless, silky transitions in position, scale, and rotation between different states. This procedural animation makes every subtle movement of the AI feel incredibly vivid and lifelike. This game adopts a non-photorealistic rendering cell shading art style, implemented on top of Unity 6's URP pipeline. I designed a unique realistic anime visual language. By customizing the cell shading shader, I softened the realistic lighting and shadows while emphasizing outlines and color brightness. This style not only ensures that the dense power grids and cables remain highly readable on screen, but it also creates a unique atmosphere that blends cyberpunk industry with anime. It's visually appealing and fits the game's genre and theme perfectly. To maintain a unified and consistent art style, all voxel-style base models in the game were manually modeled by myself using Blender 5. Furthermore, both the game's opening animation and the main menu's looping animation were procedurally generated using Python's manim math library, with all code written entirely by myself. To enrich the environment, I selected two free assets from the Asset Store, Skybox Series Free and Simple Water Shader URP. Here are their official download pages on the Unity Asset Store, ensuring the project fully complies with copyright requirements and legal usage. That concludes the demonstration of Project PSE. From the initial game design to the construction of underlying graph algorithms and AI state machines, and all the way to the upper-level UI, cell shading pipeline, and procedural animations, this project was entirely full-stack, developed by myself in Unity 6.3. I hope this showcases a game that successfully combines gameplay depth with visual aesthetics. Thank you very much for watching my video demonstration.